we are going to explain the properties. We are going to see the pig Latin statement and functions. We saw that of I query language. Now we'll be talking about pig now and the relational operators. So they're almost like the same, but let's see how it is in the concept of in the word of pig. I know sometimes I just thinking about all these big tech companies when they want to name applications, they just name application with funny names, pig. I don't know why those how those guys think through and say, okay, let's give it pig. And somebody will come one and say, oh, let's give it toad. Oh, somebody will come, let's call it python. And somebody will come and say, I prefer anaconda. So regardless of the naming, the nomenclature, the major thing is what it does and it's doing our work for us. Okay. So introduction to pig. So the MapReduce model cannot handle anonymous data sets well, and for execution of huge volumes of data, its feasible solution is pig. So what makes we said something about last week, we said something about Hive being able to help us manage relational, or let's say manage our relational environments on the Hadoop framework. We see that with Hive, we're able to write the normal select statements, we create databases, we create table, we do some arithmetic operation, we do some left outer join. And in the real sense, what runs at the background is advanced MapReduce job. So likewise, what Pig is also sitting on is a MapReduce job. So there's no way we can interact with Hadoop file system without going through MapReduce. So all these solutions are applications built on MapReduce to simplify the job. So now, when you're working with massive data set, like enormous large data set, uh, the architecture of MapReduce might not be helping. So there's a tool called Pig. As likewise, when you see the word of Flume, it is used for streaming massive data. So as much as you can use MapReduce to do something, but there are optimized process that sits that optimizes MapReduce to handle enormous data set. And when you talk about data migration, we talk about Flume. Though all those guys sit on MapReduce, but they are optimized processes and optimized application. So pre-programming language, like you have languages now, like you have your Python, like you have your R, like you have your Java. So now Pig is also a programming language that can handle structured, semi-structured, and unstructured data. So that's the interesting thing about Pig. Pig is a scripting language developed to automate the process of design and implementation of MapReduce application. So that's what I'm saying. I said all these guys, what they still sit on, the background is still MapReduce, but the casing, the interface, it's an optimized application that makes MapReduce easier to use. There's a term in programming that they call wrapping. So the word wrapping is when you wrap a programming language, a source programming language, to be able to interact in another language. So you see some people wrapping up. It's possible you wrap up Java, or let's say most of the time you start from, let's say, C sharp to work in Python, or C sharp to work in R. You see them wrap up S to R. So it's like a transition from one programming language to another programming language. So likewise here, so what is happening here is what they call it just like a package wrap up, a language wrap up from MapReduce that is sitting on R, that's sitting on Java, to another programming language called Pig. So I said Pig programming language is easy to code and maintain, and that's always the beauty of you transitioning from one language to the other. So when you discover that okay, this language is very difficult to use, okay, how can we wrap it up to something that is easy to use and so that people can easily interact with it? So they wrap it up to a new environment. So and maybe with time discover that okay, we still need to find a way to um, optimize this process and make it easier to use. They wrap it up to another simpler level. So now Pig is like something like that. It's like a transitioned language from, let's say, MapReduce as the source code to a Pig language that can be easily maintained. So it's a Pig as an optimizer that helps in smart and data processing. So that's that. So like I said earlier, it's always there to optimize your process. So we have what we call the architecture. How does the architecture work? So we have the Pig Latin and the Pig Latin compiler. So now we'll go through first of all what we mean by Pig Latin. So Pig Latin is a high-level programming language that facilitates development of data processing and analysis program in Pig. So when you go online, you see they will ask you, okay, do you know how to use Pig? You hear of scale as much as you hear of or other big data languages like Scala. So likewise, we have Pig, which facilitate the development of big data processing. So when you want to do your high-level programming language, you have Pig Latin for you, and it also operates. Says Pig Latin operates on the language layer of Pig. So we also have Pig Latin describe a direct acyclic graph in which the edge depicts data flow and the nodes depicts operators that processes the data respectively. So we are going to see this in future slides. What we call DAG, and which is the workflow Pig Latin sits on. Okay, now Pig Latin compiler. Previously we said something about the Pig Latin, which facilitates development of big data processing and understanding that it sits on Pig language. So now we're talking about when we move into Pig Latin compiler. So how does this guy work? He said Pig Latin compiler converts Pig Latin code into executable code. So I know you guys are familiar with what they call compiler. Yeah. So and what Pig Latin compiler also does for us is it's execute code. It's the executable code can be executed as MapReduce job, a process where a virtual Hadoop instance is created to run a Pig code on a single node. The figure on the next slide shows a relation of Pig to Hadoop ecosystem. So we've seen this. So now like I always say, your your HDFS is like your window. That's where every other thing sits on. So we have what they call the resource management. That is your yarn. So what's the full meaning of yarn?
Yet another resource.
Okay, fine. So now, so that's the guy that does the resource manager. Like so, this guy is yes. I'm trying to see one applications that almost looks like this guy. The other system that so you yeah. I think that's in my mind. But this guy is in charge of negotiating resources between applications. I say, okay, this this resource, this node needs a particular resource. Okay, how do we distribute resources? Okay, which one is live, which one is down? So how do we manage them, and how do we make sure everything is in sync? So now when we have the Hadoop distributed file system, we have the resource management. We also have the what we call the processing framework. So after the processing framework, we now have the pig. So starting from the pig compiler, when you write your script, it processes it into a map reduce. The resource manager allocated the resource for the job, and the action is taken on the file. So likewise, so so far it's a map reduce. So when it has an inflow, there's going to be an outflow. So the map reduce and the outflow, the map as the inputs and the reduce as the outflow. When you get your results back to the screen. So that's that. So you keep it in mind that you have your storage, your resource management, and I think by now this picture should we should understand this. This should not be a problem for us. So understanding also the distributed file system is always at the base, and you have the resource management, and like the map reduce, then you have the peak. So that's that. So furthermore, we're talking about the advantage of pig Latin. So programming with pig Latin is beneficial in the following ways. Easy to program, so very easy. We're talking about programming. When we go to get to the practical class, we're going to see the simplicity of the programming with pig Latin. And we talk about the optimization opportunity, and that is one of the thing I enjoy about pig. That's the optimizing the process, like what you think this is going to take time for it's an optimized process, and especially optimized process of a map reduce job at the background. And its extensibility. Pig Latin allows programmers to easily create their own custom function. So you can create very extensible. All right. So okay. Uh, Properties of Pig. We'll run very fast. Pig programming language is written in Java. As we know, it should be written in Java. So far, it sits on MapReduce, and MapReduce is a Java code. So the programming language is written in Java, hence it supports Java properties and use Java notations like the way you write your normal Java definitions. In in an active peak session, the Hadoop properties can be specified with D options and peak properties with P options. So keep it in mind that when you are specifying a property that is Hadoop related, you see the D option, and in the peak, when you see P, you know it's a peak property. So the set command can be used to change individual properties in grounds. That's another properties. The peak Latin properties support the following proceedings order. So you need to start with the D options, that the peak property. So I'm coming. So you need to start with the sessions. So after the session, you see, like one of our points I said in active P session, the other properties can be specified with the D option. So the first in 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 precedence, we have the D peak property, we have that of the P itself, and we have your set of command. So before you have your set of command, you need to have your D option and the P option first before you have set of commands. So Peak does not interpret the Hadoop property that are directly passed to Hadoop. So and also the Hadoop properties support the following precedents. So we see the Peak property precedents. Now the Hadoop precedents. So you start with the Hadoop configuration file, the Hadoop property, the property files, and your set of commands. So what we are only bringing in here for that of peak, we will talk about the peak property. But for that of Hadoop, we talk about the Hadoop property, and that follows the Hadoop configuration file. There's always the configuration when anytime you are working with. I know what I've seen this, that anytime you are working with Hadoop, we always have the configuration file somewhere that you need to set up and connect to the Hadoop. Then you talk about the peak. Now you now talk about the set of commands you're running.
You said was clear.
Yes.
There's someone.
Okay. Uh, Thank you. Okay. Yeah. So another table we are having here is we are showing the properties that we have in Peak. So there are different properties that we have in Peak. So please you need to refer to the student guide, especially to guys on the engineering part. So we have the verbose property, the brief, the opt multi-query property, the stop on failure property. So like when you go to your student manual, you see the full description of what all these guys work for and the possible values. So is the values can either be true or false, and but by default, some of them are false. So, but I can bet you that the default value are the values to optimize the procedure. So you should only alter any of the value given that you are very sure of what you need to do. Like option of the multi-query, disable multi-query, by default it is false. So you should understand that these values, they are default, and they are the well optimized options needed for the job to be done. Okay, so knowledge check. Um, Please, guys, please, especially to the engineering guys, please, all questions, please always answer all questions because of the exam. Like, some of these questions will appear word for word in your exam, and that is the online certification exam. Please take note of all those questions, and before your exam, provide answer to all of them. Okay. Now I think you have a good one whereby you've given the answer. Okay. So running peak Latin statement and peak commands can be executed using various methods. So the first method we have is what we call the local mode. So now the local mode is a case whereby all the scripts runs on the single machine. So without requiring Hadoop MapReduce and HDFS, this can be useful for development and testing of peak logic. So this is just a case whereby I feel like, okay, The local mode. I know there was one of our classes whereby we also talk about the local mode. I know that was when we are talking about um, debugging or optimizing MapReduce job. So in same means it's not necessary you have Hadoop on your system. You can run your pig and test run it to be sure it's running. Just as if you want to test run the logic and be sure my logic is what my statement is logical. So that's what we have. That's what we call the local mode. So on and also he said to run the pig script in local mode we need to do the following. So we'll get to understand this more in our practical class. So but keep in mind all these steps and how do we move it. So he said, oh, you move it to the peak temp directory. So and we execute the following. So like the peak x local script local.peak. I know you have tendency you have questions like this in your exam where they ask you, okay, how do you run peak script locally? So you keep this in mind. So understanding how the syntax looks like. Okay. So you get to understand this better during the practical sessions. So okay. So and also the peak compiler is the guy that stays in the middle here. So we talk about local job runner and we talk about Hadoop cluster. So your local job runner, when you don't have an Hadoop environment, like you don't have Hadoop installed, you just want to run it locally. So you run it this way. And previous slide shows us how we can activate it and how we can configure it to run locally. So if you have Hadoop installed, if you now want to, so me I'll call the local job runner like just the test environment, while the Hadoop cluster is like the development environment whereby you want to push it into production. So then you direct it back to the Hadoop cluster. So but after being sure that you've tested your job locally, so that you are sure that okay, the logic of the script is correct. All right. So now, on the local mode, so like we said earlier, the local mode um, does not require Hadoop. And one other thing we need to keep in mind is it doesn't require we making use of Hadoop. So it's not necessary to have Hadoop. And also another thing is that it is always useful for developing and testing. So that's what I said earlier, that okay, the local mode is like the test environment. So and the main job, okay, let's say the map produce mode is when you are connecting to your Hadoop environment. So and also keep in mind that the local mode data access is through the local file system in a single machine, and local mode is a separate process outside the peak Latin compiler. So just keep all this in mind, and we see thousands of things that runs beyond at the background of the processes we're running. So aside the local mode, we have the map reduce mode, which connects to which I call the deployment, the development, or let's say the production mode. So whereby your script, your big script connect to the cluster. So the pig script gets converted into a series of MapReduce jobs that are then run on Hadoop cluster, and that is what is expected from a pig script. All of them must be a MapReduce job. There must be a conversion that speaks back to MapReduce. Okay. So talking about running pig in a MapReduce mode. So talk about running pig in local mode. Now running pig in MapReduce mode. He said, how do we do that? So we have how we set up our pig in our MapReduce mode. So let's keep these guys in mind. And so, but it's just, I know we are familiar with like this option 3 saying Hadoop file system, copy from local. You copy the file and set the pig class path environment variable to the location cluster, blah blah, and the likes. So, but we'll be seeing this more in our practical sessions. Okay, moving forward.
Hello, sir.
Hi.
Yeah, sorry to interrupt. I think some people said they're in lobby. Daniel,
Okay.
you just add him up.
Okay. Thank you.
Yeah, sorry, one more question. I have a question actually.
All right.
Yeah, you've been going through these slides now. You mentioned our hints for our exams. So I was going to ask before you started this slide, or what I can see basically is this is the SBDE. This slide is for SBDE. And I know that the
Yeah.
examination we are supposed to write is ABDE. Is it possible we get questions from this SBDE aspect?
Yes. There are a few questions you get from SBDA. There are few. No, but sincerely, any question that is not in your own SBDA, anything you have to know is inside your SBDA. They won't cross. They won't pick question from here. No. If you dwell more on SBDA material alone, that's sufficient for you to pass. So you are just coming here to have a grounded knowledge, so that when you are, because there are some engineering that you do on SBDA. So I know maybe when you guys get there, you get to point of where you are installing, where you guys too will be installing your MapReduce packages for R and some other engineering parts like that. So when you understand this now, by the time you get to your own engineering part, because you are still going to do a bit of engineering, but I think that's towards the last part of SBDA, where you see some big data engineering courses there. So, but the essence of this is that you keep it in mind, that so that when you get to that time, you'll be able to understand and just keep notes. But I can tell you that all you need is inside your own material. So you might not need to read SBDE material to pass. No, you don't need that at all. Okay. So okay. I think this is a continuation of the setting up of MapReduce mode. So the engineering guys, please the engineering guys, are you guys doing hands-on? Are you guys trying the material at home? Because it's possible you test SB DASCA material. They are, to me, they are easily understood. You can just pick the practical material, practical workbook, and you do those examples. So I'm sure everybody.
Yes, sir. I'm here.
How far with your practical sessions? How are you engaging yourself? How are you getting things done? But all these things, like there are things you can just copy and paste word for word, and it's going to work for you. So you guys just need to test it and be sure, okay, these things are working, and see, understand it. So what's up with your practical session?
Okay. I was the one who just asked this question. The question about the exam before
Okay, you
now.
are
The asking about was the exam Octave told us we are going to write is for ABDE, that's Associate Big Data Engineering. So I'm
okay.
asking the question: is it possible we get questions from senior big data engineering aspects? I'm
Yes.
not talking about data analyst. Okay, so we can get questions from senior big data.
Oh, okay. Sorry. Yes, yes, yes. You get data from senior big data engineering because it is still the same, almost the same curriculum.
Okay, okay. So
Yes.
concerning the lab, actually we've actually been we work on some things on our own. We engage ourselves outside the class. But the thing is, I noticed is that at times there are some things that are different in the lab compared to what exactly we are supposed to do. Okay, eventually the solution might come out in the code snippets, text file we have with us. Like the solution to the problem might be there, but it might not be understandable. That's just what I noticed. What is in the lab is not exactly what will give us this output we expect. That's what is in the lab workbook itself.
Okay.
So we
But
have to
the
probably think out our probably wait for the class for Tim Lola to give an insight on what exactly is going on. Yeah, that's just
okay. So like what you said is logically correct. So sometimes what you see, the code you see on the workbook might be different from what was provided in the code snippet. So most of the time, so what I would just advise is work more with the code snippets, go through the code files that was shared. So at least the code file is to some extent always correct. Some extent always correct. Okay, no problem.
yeah. Thank you.
You're welcome. Okay. So the application flow. So that there's a flow, like when you're writing any programming language, they're like, okay, maybe you want to build a package, you're like, okay, you define your class, you define your input variable, your output variable, let's say, and the body and some other things. Like, so likewise in Pig Latin, there's a flow that the programming language follows. We have there's what we call the data flow language, and in Pig Latin, a data stream is defined and a series of transformations are applied to the data as it flows through the application, and also the data processing data flow illustrated below. So now we always have what we call the load. So like this is like the input. So like the same methodology that we do have for this guy, for MapReduce, whereby you talk about, you have your input file, you have your, I know in MapReduce you talk about the key value PS, but now we are talking about the data processing operation. Now is like the reducing part. So because that's where you do your data aggregation, you do a lot of manipulation. You have what they call the dump B, that's the result of this guy, and you have a place whereby you write your file, where you say store B into file name. So you have your file, you have the transformation, you have, like, if let's assume you are writing, you are working with Python, you just say, okay, you have a table and you are converting that table to a data frame, and from that data frame you are writing it to CSV. So that's just this two process. So now two processes. So you have the dump B. So from the dump B, you now write it to a particular file. When you're writing to a CSV file, I say, okay, write this file to CSV. So that's the same methodology that this guy sits on. So on the load statement. So we are going to talk about the four major processes. So starting with the load, the first part, the load statement. It said the load statement is used to read data to be manipulated. Basic. To manipulate it from the file system. Data is stored in your file system. To access the data, the load data file, the load with the data file name command is used in peak programming. Transformation. So that's why I said something about the transformation. Transformation is when you do your reduce job, when you do a lot of transformation, your aggregation, lot of things. So your transformation can be the big guy that does a lot of things for you, whereby you put in all your possible logic and possible data manipulation, data extraction, and the likes. So it said a series of transformation statements are implemented on the data to process the desired result. The commands are translated into a map and a reduced task automatically. So that is this. So these are things to keep in mind. You keep in mind your load statements, you keep in mind your transformation statements. Okay, so also have the dump statement. Dump statement is used to view results. So the dump command is used to send the output of the screen while debugging the program. So, and that's that. And we have the store statement is used to save the results. Like the example I gave earlier on said, in Pig, the storage of data is done on HDFS in tab delimiter. Beautiful. So file with the help of Pig storage. So just keep those things in mind. Keep the load statements in mind, the transformation which translates to a map reduce job, and keep the dump statements, and that is what gets the like to me. So like it's like your time table, and you have your store that converts it to a tab delimiter file system. So so please guys keep these guys in mind. Keep them in mind. Beginning with Pig Latin. So now, see now how Pig Latin works now. I said Pig Latin is the syntax of language for Pig programs. So Pig Latin, Pig translate the Pig Latin script into map produce job of explaining that. While developing Pig Latin script, follow this design principle. Like say, keep it simple. Some people just like writing complex scripts. As much as you can, keep your script simple, like as simple as possible. Said keep it simple. Keep Latin. Pig Latin provide a streamlined method for interacting with Java MapReduce. Also, complex tasks may require a series of interrelated data transformation, and such series are encoded as data flow sequence. So you understand with time the data flow sequence in a job workflow. Okay. The first part we talk about was making it simple. Now make it smart. Writing a smart script is a function of your ability to think smart. Like I think to a good data engineer, 90 or 80% of your time, of your thinking, of your script should be looking for a way to get it done in a very smart way. And maybe that's something I need to say it's a good soft skill all data engineer must have. We are faced with one challenge in one of our projects whereby we need to find a way to get things done in a very smart way. I told you last week Monday that we try to optimize a script from 1 hour 12 minutes to 12 minutes. That can only be done when you know how to write a smart script, whereby you know, okay, these things are not necessary. So instead of me writing this, I can write this. Smart way of getting these things done. One of the smart way of getting things done is reducing the possible line of code that you use in getting a particular task done. For instance, I remember when we are having the IQL class, there's something whereby maybe I wrote two scripts, two different statements to do one thing, and you can still write one line of code to get the same thing done. So, and that is working smart. And when you're working with Pig in production, it is always advisable you write with the most minimum number of codes. I know with time you get there, maybe as experience increases, you see how you get things done. But it is always a good thing to work smart. So it says something, structured query language is a setup of declarative query that you use to access structured data stored in RDBMS. The cost-based optimizer chooses the most efficient approach for execution. So that's working smart. Don't limit development. This refers to the principle of making Pig extensible. Extensible is you being able to create your own customized package or function from it. So don't limit development. Don't make it closed. Make it dynamic. So, and that's that. So that's things you make put in mind. Okay, these are things we need to know. So now, the data type that pigs work with. Now, what are the pig data type? As we know, said pig data type makes use of data model for how pig thinks of the structure of data it is processing. For every programming language, how the programming language reacts to the data or to the input file is a function of the data type. How R, I know you guys have been working with R, how R will treat metrics is different from how R is going to treat a data frame, a normal data frame, or probably on how a particular operator will treat a vector or, or probably a normal integer type. So that's what I'm saying. Said how big things of the structure of the data it is processing is a function of the data type. And also keep in mind that any data loaded into Pig from a disk is going to have a particular schema and structure. Pig needs to understand that structure. So you need to understand, okay, what's the structure of the data file that is coming in? And I don't think this is a big deal or probably something new, a new logic that we're just trying to understand. All other programming languages also work with the same methodology. He said Pig needs to understand that structure. So when you do the loading, data automatically goes through a mapping. So see the Pig data type, the scalar type, singular type, and we have the complex type contains multiple values like tuples and the likes. And these are things we are familiar with. But we should keep in mind that what is peculiar to P data type is we have the scalar and the complex type. You know, so I will have thought of saying something like scalar. That is just a point. We talk about a vector. That is a list of scalar. I'll talk about the matrix or data frame. But in terms of pig now, we have seen pig having what we call the scalar and just the complex. So it's either your scalar or your complex. So inside the complex type is where you have your vector and lots of tuples and the likes. You have multi-dimension tables or multi-dimension inputs. So that's one thing we keep in mind. Okay. So on a wider note, type of data we have for pig Latin, we have what we call the atom, which is equivalent to the scalar we saw in previous slide. Said an atom is a singular value, and that's fine. So I think it's the name depicts what it should be. And we have what we call the tuple, is a record that consists of sequence of fields. Each field can be any type. So we talk about tuple. So to me, tuple will now be like a data frame. Bag. A bag is a collection of non-unique tuples. Each tuple in the collection can contain an arbitrary number of fields, and each field can be of any data type. So now, this bag is now, so if tuple is like a data frame, like a table, so a bag is now having multiple tables. And now let's talk about map. A map is a collection of keys value pair. Any type can be stored in the value and the key needs to be unique. So, and that's that for a map. Like, okay, when you talk about mapping something, you map A to B. So that means you must have a key and the corresponding value. All right. So moving forward, the figure below shows example of tuple bag. So, okay, like what I explained, atom is just one entity. So when you have your atom, so after atom, the next thing we have is each row is a tuple. So each row like this is a tuple. So based on this definition now, atom is a value, tuple is a row, and the bag is the table. You see, so this is like this whole stuff is the entire table is a bag. Each unit is an atom, and each row is a tuple. So those of us that were used to Python, so if you want to create a tuple, is always like a vector like that. So, but no, it's going to have, okay. So the beautiful thing about this is that it can have different data type. We can have both integer and character arrays. So that is that. So any question? There are no things are self-explanatory. They're like self. So the peak syntax. So we have the implementation have lesser codes that are easier to understand. That's one thing you get on the have your hands-on practical. Pig Latin has a simple syntax with powerful semantics, which are used to carry out the following, like we saw in previous slide. You have it to access data and for transforming. So, and after you transform, we talked about you returning the row, the result. You tab delimiter format. Okay. So is access so you said you read data. That dump is what I equate to Python. So read memory to for the system to understand. And the first way we load data, and another way is we stream. So it's possible that is a streaming data, whereby it is inflow of logs or files from maybe a web server or something like that. Another thing is transformation. We talk about data access, the transformation of your pig script. So the transformation part you see for each. So applies expression for each record and output one or more record. Filter applies predicate and remove records. Normal filter and rejoin two or more records based on condition. So these are still basic things that we are used to before now. But in case you have any question, please, I'm just trying to run very fast because we have always a lot. We still have the last session to run, so I don't want to keep it over. So we have a debug. One thing about Pig is that it also provides a few operators that are helpful for debugging and troubleshooting. So we have the describe, dump, and explain. I know the explain. The explain operator. We also have that in the IQ. So to tell us the real definition of maybe a particular function that we are making use of. Okay, what is the expected input files? What is the expected output? So these are guys that does that for us. Okay. The Pig script interfaces. So we have like series of interfaces that we can use to execute a Pig script. So a Pig program can be packaged into the following three different ways. Script. And this method involves saving a file containing Pig Latin command, your normal script, by the Pig suffix. The commands are interpreted by the Pig Latin compiler and executed in sequential order. So we have your script. So like when you're working with Jupyter Notebook and you have different cells, so it runs from cell 1, cell 2, cell 3. So that's the same way. That's the same procedure that a script file is used in running. Grunt. He said Grunt acts as a command interpreter where user can interactively enter Pig Latin at the grunt command line and immediately see response. This method is helpful for prototyping during initial development and with what if scenario. So it's also it's gonna help you. So now this looks more like your R studio whereby you see your outputs and you're able to see in case if anything goes wrong, then you're able to pick it up and say, okay, something is wrong, let's fix it. So we also have what we call the embedded Pig interface. So The pig Latin statement can be executed with Java, Python, or JavaScript program. Pig script runs shell pig command, and embedded pig programs can run in either local mode or MapReduce mode. So let's keep this in mind. Let's keep it in mind. These are things that are going to aid our understanding when we get to the practical session. Okay, so and also keeping in mind that the grunt shell provides the interactive shell to submit pig command. So we are going to see this more, especially to guys on the practical on the SBDE stream. Okay. Scripting with pig Latin. Hadoop is a rich and quick evolving ecosystem with a growing set of new applications. Pig is designed to be extensively through user-defined functions. So, like one of the attribute of pig is that we discussed some minutes ago is that when you are writing a pig script, you make it extensible such that in future time when somebody wants to modify or probably make it revolve easily, your code will be fit for those kind of situation. So, and that's why I mentioned something like you make your script dynamic, and as the ecosystem, as Adobe ecosystem is revolving, there is no way we can run a process that will not be dynamic or that will not be flexible, because every day people are changing, their new updates happening. So same way, it should be able to script pig Latin is able to use user-defined functions. So some of the pig user-defined functions that are part of the repository function, like date time, function text, blah blah blah. Standard UDF are written in Java and packaged in Jar files. An executable UDF is created by creating a Jar file containing the UDF file class file. So so that's that. So I remember that during our Hive query class, we said something about creating a user-defined function, and that function was like upper class. I know we said something like upper class function, whereby to write that file, you need to write a well-defined a Java programming code to get that done. So likewise, Pig also supports those type of system whereby you create a user-defined file using your Java program. So that an executable UDF is created by creating a jar file containing UDF class files. So that is that. Also, to use UDF in a pig Latin program, you usually need to register the jar file with the pig using the register statement. So you can see the register statement, say register pig bank. So it's just a way to make it accessible, make your function accessible. So it said register pig bank, Java pig bank just jar. So you know you are just calling your jar package. So and another thing is you see the for each. Let's say for each A generate this. So so this is where this is how we call the piggy bank function. So it's something that is not so, it might look abstract for now, but with time we will understand better the beauty of this tool. Okay, I'm coming. Okay, so while executing some program, the UDF needs to be called multiple times. So I think this is interesting. So this is the same function that we use for IQL, whereby we have a function called upper. So now in this case now, like when you want to import a package in Python, say import pandas as py. So the same thing here is like, say, while executing some program, the UDF needs to be called multiple times. The define statement can be used to assign a name to a UDF which has to be called multiple times. So now the name that was specified to it is now upper. So you see, by using the define statement, user can avoid writing the full qualified class name. So now, like, this guy is the full qualified class name. So but now that you've given it a name, you can just call upper. So then you have your results done. So you can write the above UDF as this. So after registering your piggy bank, you call your upper functions, and so far it is defined as upper. Then you can use it to perform any operation. So that is that. Now to the last part of our presentation for today. So Pig also supports categories of UDF. Said evaluate on the evaluate mode, said most UDFs are evaluation functions that accept one field as input and return fields and outputs. You have the load / the store functions are just used only to load and store statements. So that is that. And another beautiful thing is that it can be written using the Pig Java API. So you can use the Java API to write it. So also we have that an eval UDF can be created by making a Java class that extends the abstract evaluation function. So when we get to the practical session of creating a UDF, you will see how we go about these guys in a more deeper note. The best methodology to create UDF is to first start working. It is similar UDF. So you start from known to the unknown. So if you want to create a user-defined function, start with how do you work with a working UDF. So when you know how you work with that, then you can know how you create your own. So you see few considerations when you are creating UDF functions. You see the filter functions, the eval function such as filter function returns a boolean. Such functions are used in pig Latin filter and split statements. So you see some of the UDF functions, the filter functions, the aggregate functions. So the aggregation functions are like your mean, median, like the sum, the average. And also keep in mind that the aggregator function are implemented on grouped data. So you must have a categorical variable while working on your aggregation function. I think that applies to even SQL too. Okay, so parameter substitution. So there's something we call parameter substitution. So P can overcome limitations such as provision of data flow techniques. To embed P within a host language, the statement needs to be compiled behind to a parameter and then executed. So I'm trying to see the best explanation to give to this guy. By embedding pig within a host language, pig can overcome limitations such as provision of data flow techniques. So do you know I remember we're doing something now whereby we are writing we wrote SQL in C sharp. So we are trying to run a C sharp query, but the query needs to execute an SQL code. So at the process of you hosting a pig script in another language, like if you have another language hosting your pig, there's what we call parameter substitution. So that is where you create a parameter to hold it. It's just as if you want to declare a parameter like a placeholder uh, to hold your state say your pig script. The point two says to embed pig within a host language, the statement needs to be compiled behind to a parameter, then executed. So it's just as if you've written your script, you've compiled it, and you now deploy. Yes. So just as if you now call the API within the host program such that your call is now referencing your compiled pig program. To write a reusable script, it is generally parameterized in such a way that the script can change its operation for each run. For example, the script may ask the user to provide the file path of its input and output each time it is executed. So using parameter substitution, Pig allows user to specify such information at runtime. Beautiful. So when you call a function, you can ask it to specify the parameter and say, okay, you parameterize it. SQL itself even does this. So you can parameterize SQL statements such that when you want to run the query, it's going to ask you for a particular value. But keeping in mind that it must be a compile, your pig file must have been previously compiled. It's a parameter denoted by the dollar prefix within the script. So making it more clearer, when you use a dollar prefix, that means you are asking the user to specify dynamically the inputs of the script. If, for instance, now I want to write, say, give me, I'm writing a function that says, give me the score of students greater than a particular parameter y $y. So anytime I run it, it's going to ask me, what is your new value? I can say, okay, my new parameter value is 50. So it's going to give me students that that has a score below 50. I can change it and say, okay, maybe in the next run, I want to put my parameter value as 70. It's going to ask me, okay, what's your new parameter value? I put it, okay, my new parameter value is 70. It's going to do that for me. And also in the same manner, if I'm to export file, if within my script, I need to specify the output. You say, okay, specify, please, what should be the format of, or let's say, what should be the output name? Then you put it, and then the process runs based on the input parameter. So, so that is that. You are collecting sales data about automobile manufacturing company. You found out that the schema of the data is varying and contains an arbitrary number of fields. And each field can be of any type. In this situation, which of the following big data models will you use to store the data? So this is a question to the class. Topo. Yes, because you have different data type. Okay, thank you. So you have answers here. While accessing data using pig, which of the following method will you use to return an ordered list? So I know we never studied this here. So this will be, you can see this in your lab manual. Okay, relational operators in pig. So for each means for each record, like it's just like you are doing a loop. You say for high in 1 to 10. So for each record, so he runs it on the while loop. That's what the for each works. And you see filter, group, order by, distinct, join, limit. So limit and filter, they almost work like the same. And you see sample. So sample is okay, out of 1,000, please help me sample like 220 sample based on percentage. So these are basic relational operators that we have in pig operators. So now for each, on the basis of predefined expression for each operator, I treat every record to perform a transformation. So like I said, for each this, so it speaks row by row. Filter statement contains predicate that helps in choosing the record that needs to be retained. So just filter is equivalent to, let's say, where like in SQL, say select star from a table where age is less than. So that where statement is equal to the filter here. So because it's one that tells you the first level condition. So filter alias by expression. So we can read this up. So group statement is used to group data into one or more relations. So one thing I understand about group is you must have what they call a categorical variable in every group function, and you must have your aggregating function. So let's see the syntax of the group statement is alias, group alias, all by expression blah 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 blah. I'm trying. So oh, the best way to explain this is when we see um a big script. I'm sure by our next class or maybe before the week runs out, if possible, we see this. This is still a bit abstract, so but we should keep in mind we have the group, we have the order by, um, we have the distinct. So when you say select distinct, non-repetitive, that's distinct. Sample can be used to select a random data sample by starting a sample size. By stating the sample size, the sample operator expresses the return percentage of rows in double values. So you can sample in numbers or in percentages. So either you say sample 10 or you sample 5%. So it's going to estimate the corresponding value. Okay, so we have the limit function. So I said limit, select the top 10 record. So the input function for the limit function is n. We're going to select a particular number. So join, we'll be hearing of join. So different kind of joins, inner join, equi join, left outer join, and the like. So, but the syntax, we'll see more practical syntax during our practical classes. So, okay, we're almost through. Point to remember. So, somebody's there. So, point to remember. The traditional method of Hadoop programming involves map-reduce model. It consists of the following phase: phase one, map, and the phase two. The solution for okay, it's recording. So the solution to Hadoop execution problem is Pig. So a scripting language that automates the design and implements the MapReduce application. So and Pig language layers contain textual language called Pig Latin. We'll see this more. We see it in a more practical class. It's Pig Latin will use a temporary table because it is more reliable. And you see the directed acyclic graph. So, which is the methodology for Pig Latin. I know there was one question, I saw this, there was one NASCAR question. I saw this question, which they ask, what is the methodology for Pig Latin? And I know the answer was direct acyclic. So they would have seen it once. So keep those things, little things in mind. So element of pig, you have the pig Latin, the grunt, the piggy bank, and the advantages is easy to program, optimization of opportunity, extensibility. You can create your own user-defined function with pig. So pig Latin use cases generally fall under the following three category: traditional ETL, research of raw data, iterative processes, and Pig Latin differs from SQL in the following ways: design of outputs, multiple data operations, and the environment. So that's the way, that's the that's how it varies from this guy SQL. You see this in clear terms when you study Pig. But please, you can go online and research about Pig. All these things are simple. Outside Daska, you can decide to understand Pig in 2 or 3 days max. Just go online, read randomly on Pig, do basic Pig syntax and discover it is simpler than what you think. Pig Latin will use a temporary table because it is more reliable, like what we saw earlier. SQL is designed for relational database management environment. Pig runs on machine from which you launch Hadoop jobs. Pig Latin statements and Pig commands can be executed using various modes. We talk about the local modes, the map reduce mode, iterative modes, and batch mode. I know this for today's class we only dealt extensively on local mode and map reduce mode, but we never talk about iterative or batch mode. But we should keep all these things also in mind. The iterative mode and the batch mode. So, and keep in mind data type, the expressions and functions, the user-defined functions, and the parameter substitutions, whereby you can call in dynamic parameters during executing a Pig job. So that is that. Any question? And please, please, you can just spend, if it's just 15 minutes, research on Pig. These things are more simpler than you think. Just research on Pig. Just spend 10, 15 minutes or 20 minutes. Just go to the internet and see Pig language. How do you write it? They are simple. So thank you very much. Any question? So, okay. So if there's no question for me today, thank you everyone for your time. Do have a blessed day, and please read, take a little more time to research on these things. Thank you.
All right, sir. Thank you very much, sir.
Thank you, sir.
Have a wonderful rest of the day.
Thank you, sir.
Thank you, sir.
Hello, Hubert. You can leave the class now, Hubert. Class has ended. You can leave the class.